Okay, so this is the second part of the kinematic topic. We are going to use integration and differentiation. So let's quickly recap. Given the displacement, how do I find a velocity? Velocity is the change in distance over change in time. So I'll have to ds dt, you've done your homework, you should know this. Now, acceleration is my speed keep going faster and faster. So my speed keep changing. That's acceleration. In order to find acceleration, change in the speed over the change in time. Okay, so that was what we did previous lesson. Now we got to go reverse. If I'm given a acceleration, how then do you think I can find the velocity? Yeah, I will integrate A. And please remember, later you have plus C. Okay, so it's a bit harder because you need to find the C's. If I'm given the velocity now, how do I find the displacement? I will integrate V with respect to time. So if I'm asked to go from A to displacement, I need to integrate twice. And I need to find two C's. One for V, one for S. Okay, so I got two C's. We will see in the last example. Okay, let's answer this question. Okay, let's find the acceleration after 4 seconds. Given the function V is 4 minus t squared. So the question is, I need to find acceleration, then just tell yourself what to do. This topic very straightforward. So I need to d V over dt. Answer is, what do I need to do? The question says after 4 seconds. Sub what? So you have to write this down, sub t equals to 4. dv dt is very simple. Okay, please try to put the units now. Meter per. Now, what's the meaning of negative here? Yeah, that's a deceleration. Okay, that means I'm getting slower and slower over time. Okay, that's all. Very simple. Part B. I now need to find the distance. Okay, so I need to integrate the V, and I will have 4t minus t cubed over 3. What's wrong? Problem come already, plus c. So that is my displacement. Okay, how do I find c? Of course, that should be the natural question you ask yourself, right? But how do I find c? Your mind must be thinking, I need to submit s and t, right? Your mind must be thinking, I will use 6, right? But no, it's not. So what Jimmy just said? When t was 0, okay, that's where I started. And look at the question. The starting point was when initially, where was the object? Where was the particle initially? When t was 0, it was at the fixed point, right? It was at the fixed point means s is 0. This is important. You have to write this. Therefore, c is 0. And therefore, s equals to 4t minus t cubed over 3 plus 0. Do I just sub the 6 in? Yes. Okay, I'm glad you did your homework. You must find the turning point first. So how do I find the turning point? Okay, I need to sub v is 0. Okay. 4 minus t squared equals to 0. How do you solve this? T squared equals to 4. T is plus minus 2. Okay, why do I write this way? Why don't I just write plus minus? Because I need to reject. So I got turning point. Can we do the usual distance thingy? What is the usual thingy? start, turn, end. Okay, let's start. When I start, t is 0, s is 0. Okay, when I end, okay, let's do the end one first. When t is, when I end, yeah, 6. S is negative 48. So the turning point is 2. And S is 5 and 1/3, right? Okay, I have no more space here, but you know you need to find the distance between these 2 points. The distance between these 2 points. So let's use the final formula. Distance is big minus small, and you add these 2 up. So what is the big number here? 5 and 1/3 minus the small one. Okay, down here, which is the big one? 5 and 1/3 minus negative 48. And yeah, Jolene said plus, you can write plus. And the final distance is, and we are done with part B only. Okay, I need to have highlight a few keywords, see whether have we found it already. When it's instantaneously at rest, what does it mean? V equals to 0. So Jimmy said we found it already. Have we found V equals to 0? Down here. So we found it when V is 0. They ask you what is the displacement. That is looking for S. When V is 0, T is 2. When T is 2, S is 5 and 1/3. So we still must write it down. Part C. When V is 0, T is 2. When T is 2, S was, okay, minimally write down all these texts. 5 and 1/3 meter, that's the displacement. So what's the difference between this question? I start from A, right? So I got to do C1, I got to do C2. That's the only difference. Okay, come, let's try. Okay, I need to find V when T equals to 2, so I need to find V by integrating the acceleration. And I'll get 3t minus t squared over 2 plus c. So I need a V, I need a t in order to find the c. So they tell you that initially it passed the origin with V equals to 8. Initially means time is 0. So when time is 0, V is 8, C is 8. So that's how we find the C1. And we have this. Find V now when T is 2. So when T is 2, not 22, this 2 square. Okay, 2 square. And the answer should be 12, right, in the answer booklet. Maximum V, what must I do? Yeah, dV over dt equals 0 lah. Okay, the speed function is given by this. Here, I will have maximum speed when dV dt equals to 0. Okay, highlight this. The acceleration must be 0. Okay, so the acceleration is 0. That's maximum speed already, right? And boom, then after that, at that speed, no more acceleration. That's the maximum already. Okay, so A is 0, very simple. When A is 0, T is 3. And this is my part D. So if I sub T equals to 3, I need to find the maximum V, right? So I need to sub T equals to 3. So V will be 3 times 3 minus 3 squared over 2 plus 8. The answer is 12.5. Okay, all look here, please. What is wrong here? Yeah, can you please check that it's maximum? D 2. I need to find the second derivative, right? Of what? Yeah, so it's V. Okay? So if I differentiate one time, I get this. Can we do it mentally? If I differentiate 2 times. Can you differentiate this one more time? What do you get? Negative 1. It's less than 0, and therefore it is maximum. We are done for part B. I need to find displacement. Displacement is all the way at the top, right? So I need to integrate again. Let's integrate 3t minus t squared over 2 plus 8 dt. Okay, let's integrate. I will have 3t squared over 2 minus t cubed over 6 plus 8t. What's wrong? Plus c. Okay, and I need the s, I need the t. When t is 0, s is 0. So c is 0. And please write down the new equation. Otherwise, we all keep worrying about the c. We have already settled the c problem, so just write this down. What's the meaning of when it is at rest? V equals to 0. So I want to find the time when was V equals to 0. When? Okay, scan the whole thing. V equals to 0. You have to find the time. When V equals to 0.
Oh, I just cancel that.
What is the time? So 3t minus t squared over 2 plus 8 equals to 0. Can you solve quadratically? I'm not going to solve, I just give you the answer, okay? Solve quadratically because I'm running out of whiteboard space already. Negative 2 and 8. Negative 2 or 8. Okay, so now I know the time, I can find the S. Okay, moving up here. So when t equals to 8, s equals to, put the 8 here. And the final answer is 74 and 2/3. Okay. Okay, just now when V was 0, t we found is 8. If we sub it to the s, alright, we found that, okay, s here, we found that the s is 74 and 2/3. So the last question is to find the average speed when the time is 12. So when you need average speed, you need distance. Okay, so when you're asked to find average speed, you need to find total distance. When you have total distance, you need to start, turn, end. Okay, so start is 0, turn is t is 8, and end is t is 12. We find these 3 displacements. So the total distance will be big minus small, and then big minus, sorry, this one, big minus small. Okay, and the total distance is 125 1/3, which is the distance I'm going to use divided by the total time, and that will give me my average speed. Okay, and that's all. Okay, thank you.